On your packet, I didn't want to obviously copy this all over again. So I just want to show you on your page 5. Okay, so on the bottom of, oh, there's a delay in the.
Oh my gosh, it's a lot of homework.
Okay, this is actually broken up into 2 days. So if you look at your lesson plan, the lesson plan is right. The lesson plan says assignment 34 is page 783. Okay, so it looks like one really big. If you want to put assignment 35, see, I fixed it here. So assignment 35 is just going to be page 793. So on your packets, it's going to look different. I originally had combined 2 sections into one, but I decided to split it into 1 section per day like we normally do. So page, yeah, like look at your lesson plan. The lesson plan is the correct one. So the next section, so page 801 is actually assignment 36, not 35. So if you go to page 8, it says assignment 36, or sorry, it says assignment 35 on yours. It should say assignment 36. And then,
The last one's 37.
yeah, the last one on page 13 says assignment 36. That should be assignment 37.
So is
So-
35
So this
or
lesson's
34
gonna be
over the weekend and 35 is gonna be Mondays?
Oh, it's only
Tuesday.
33 and 34 will be due on Tuesday. Everything is correct on Haiku and everything's correct on the lesson plans. I just was not about ready to print out a whole other class set of packets. I had printed this early, so.
Oh, so 34 is our homework over the weekend.
Oh, yeah. No?
That's a bummer.
That means there's no quiz on this? We should've just
There's,
had the test on
this is
Friday.
a short chapter, so we're not gonna have a quiz on this chapter.
Yay!
Just a t-
Just a test. Perfect. How about that test as a partner test?
So we have,
So down,
Okay,
yes.
this has to be a partner.
I call Rowie.
She
No,
just said
I
there was
want
no
Rowie.
test for this one, so why would you
Rowie,
want it?
Rowie, I need the one of.
Guys, you're going to cases. Stop.
Rowie,
chapter 12, there will be several quizzes. That's on surface area and volume. So there will be an opportunity in chapter 12 for a partner quiz. Quiz,
Rowie.
not test. Quiz. I don't do partner tests.
You can do partner
But this is
quizzes
gonna, so we
either.
can just have a quiz for this.
I just told you, Cameron, chapter 12, we will have a partner
but
quiz at some point. It'll be a surprise. I'm not going to tell you necessarily which one because there's a few quizzes. I think I have 2 or 3 quizzes in chapter 12. I think 2. I think 2 and a test.
Multiple partner tests?
So we're going to start chapter 11,
How about partner Bible?
areas of polygons and circles.
Corey has it down. Corey knows what's up.
So we're going to look at, some of these formulas will be familiar to you and some of them will be new. Hopefully the ones that we see in this section are all review, but we're going to have to apply some of our trigonometry, the SOHCAHTOA, in order to find the area. Okay, that's why I included some of those review problems on the last test because I wanted you to go back and refresh. Okay, so first of all, we know that a parallelogram is a quadrilateral with both pairs of opposite sides parallel. That's the definition. Any side of the parallelogram can be called a base. Okay, so it doesn't matter how you draw the parallelogram, your base can be any side. So if you look at this diagram here, I have it on the bottom, but technically you could have the base over here.
I'll be honest.
Okay.
Like,
But these 2 are congruent, these 2 are congruent, but not all 4 are congruent. That would be a rhombus. Okay? So the length of an altitude. So this word altitude should look familiar, right? An altitude is what? The altitude always has to be perpendicular, right? It's the height. Since the beginning.
we record the
Okay, so
yell?
altitudes must be perpendicular to the base. So if you're looking at a parallelogram, we cannot use the other side as the altitude because it's not perpendicular. Okay, unless it happens to also be a rectangle, then it's easy, then it's just basing on it. But here, we have to make sure that the height is perpendicular to the base. Good? So our formula for our area of a parallelogram is the same as a rectangle. It's base times height. Okay? So think of a parallelogram, it's just like a slanted rectangle, so it makes sense that they would have the same area. It's just the height you have to, it's not necessarily the other side. It has to be perpendicular. Okay, so this is where we have our special right triangles or trigonometry that we have to involve because we want to find the perimeter and area of this parallelogram. We know the side lengths, and we happen to know that one of the angles here is 60 degrees. So if it hasn't already been drawn, you draw the altitude, but it's drawn here. We want to figure out what that height is. Okay, so just think about it for a minute.
Or you could do 30, 60, 90.
You could do a 30, 60, 90 triangle or SOHCAHTOA. I would like you to also think back to the 30, 60, 90 because there are some times where we have to write the exact answer, which means we leave like the square root in the answer, and sometimes we can round to the 10th place. I would like to practice with the 30, 60, 90. So let me just review. 30, 60, 90, since I don't have it up. So if this is 60, this is 30, and that's 90. If the shorter leg is x, the hypotenuse is 2x, and the longer leg is x root 3. The 45, 45, which we encountered a few places in the last chapter, if one leg is x, that means the other leg is x, and then the hypotenuse is x root 2. Remember, 30, 60, 90 triangles are half of an equilateral triangle, and 45, 45, 90 are half of a square, like cut diagonally. Okay, so now knowing that, so you see how you have this small 30, 60, 90 triangle here as part of the parallelogram? So let's apply the 30, 60, 90. So 12 is the hypotenuse. You see this shorter leg down here? This has to be 6, which makes the height 6 root 3. So now we have our perpendicular height. Go ahead and multiply out to find the area.
Does anyone have 0.7 left?
Okay, so let's write the exact answer. I know you guys can plug this into your calculator and find the decimal, so let's just write the exact answer for now.
How do we know if it's the 18 or 12?
Okay, so is this height perpendicular to the 12 or perpendicular to the 18? Remember, you have to make sure, that's why I wrote the altitude has to be perpendicular.
Wait, so what would it look
Base must be perpendicular to the height. You have to remember that.
What would it look like if
So what would it look like if it were 12? You would probably have like this perpendicular line coming from B.
Oh, okay.
What do you get for 18 times 6? What's 18 times 6 though?
108.
So 108 root 3 is the area. Oh, and it's, whenever we have units, you should include them in your answer. So anytime it's area, it's going to be a square unit. So our area is 108 root 3. And our perimeter is just 2 times 12 plus 2 times 18. So we have 24 plus 36 equals 60 inches. And perimeter is a linear measure, so it's just plain inches. Okay, area is unit squared, perimeter squared. Okay, see if you can do example 2. Anybody want to? So now we have what type of special triangle? Okay. Now, 29.6 is the hypotenuse. So if I take 29.6 and divide by root 2, right, that's going to give us the height. I know, it's a decimal. So if you change this, since you were provided decimals, you could write it either way, putting it in exact form or rounding it. I'm pretty sure it would be to the 10th place on your homework. Did anybody get exact answer? Over 2?
No.
Oh, that's the total amount? Oh, well, I was saying you could probably that's okay. Yeah, if you were to rationalize, you would have 29.6 root 2 over 2 for the height. Right, you have to multiply by root 2 over root 2. Remember that for rationalizing? So the area is going to be 33.3 times that. I guess for right now, let's do this one as a decimal. So you said 14.8 was approximately what it was? Oh, I see. You did write it exact.
29.6 divided by root 2 is 21.
Okay. What's wrong? You didn't get that? Yeah, so if you wrote this in exact form, and this is centimeters squared, if you wrote it as an approximation, did you get like 696.98? And then go ahead, what's the perimeter? How do we get which part? So 2 times 29.6 plus 2 times 33.3. Yeah, that's what I get too. Everyone else? 125.8, and the units are just centimeters. Good? Questions? This is a pretty straightforward lesson. It's just that we have the trig or the special triangles involved. That's really the only additional information. Everything else is base times height divided by 2 for a triangle, or 1/2 base times height. Look familiar? Base times height divided by 2? 1/2 base times height, which one do you like better?
Divided by 2.
Okay, so you guys like this one. That's fine. Either one's acceptable. So let's find the area of each triangle here. I know, okay, so here we have, again, if you don't have the altitude, if you don't have the altitude drawn, just draw that in and make a right angle. So you're basically looking at this right triangle here. So we can't use the 5 at the bottom. Okay, do you see what I'm talking about here? This triangle. We'll use the 5 when we actually have to find the area, but we have to find the height here in that right triangle. So if this is the angle that we're working with, 4 is what? Opposite, adjacent, or hypotenuse? Okay, so I have the hypotenuse. And the H, is H opposite or adjacent? Opposite. Right, so if you think SOHCAHTOA, you have to use sine. So you have to do sine of 37 equals H over 4. So 4 times the sine of 37. Now this we're going to have to round. So let's round to the 10th place. Is fine for side measures. 2.4? Yep, that's what I get to. mean, that was the hard part. Really plugging into the area formula is the easy part because now you have the base, is 5. The height is 2.4. Right, so we multiply this, divide by 2. We don't use the 4 anymore. The only reason we needed the 4 was in order to find the height. What do we get for the answer? 6. So 6 square centimeters. Now we're back to what you did in like middle school.
Like, I mean, that's why I'm saying it would be
I'm
nice.
not going back to middle school. You know? That's not
Middle school is the worst time ever.
it's a lot better with trigonometry. Okay, what about B? So
It's a weird time to have
So B, we don't have any angle measures, so we're not going to be using trigonometry here. Instead, we're going to be using what?
Oh my gosh, we're using the formula twice.
Did you really just say math?
We have to find it.
Oh, yay, Pythagorean theorem. Pythagorean theorem.
Yay, Kylie!
So, Pythagorean theorem, what do we want to use here?
This square plus this square plus x
equals 13 squared.
Good. Okay, go ahead and find the height.
You know what, Alok? What? Yeah.
Square root of 133.
I won that fight. Yeah.
Okay, guys. Let's do an approximation for that. What do we get? To the 10th place.
11.5.
Great. Okay, so now my area. What's my area? It's going to be
11.5.
Times 29. 29.
Hold on, guys.
Add it and then
Look at the don't. Yeah, we don't want to. That was just in order to find the height. The actual
Stop
triangle.
yelling at me. Jeez.
Oh goodness.
It's around 160.
Mhm. Yes, that's fine. So that would have actually been better. If oh, it's 1. Or 167.2. Oh, it's 0.75. Okay. There. Okay. All right, guys. So in the next two examples, so we have these quadrilaterals, and we are given some segments that are inside of there. What we can do is use this calculus. The area of a region is the sum of the areas of all of its non-overlapping parts. So for example, like we could figure out the area of this triangle, ABB, and triangle DBC, and then just add those two together. This isn't a parallelogram, so we cannot use the base times height. So we're going to look at, so just look at the perpendicular segments and figure out, like 10 is perpendicular to AB, right?
Bye, gentlemen. Oh yeah, I do.
Okay, can you see that? No?
I mean, I can see ABB.
I can see it, but I don't know.
Where do we get it?
Okay, you understand why you can't use base times height because it's not a parallelogram. So then we're looking at inside, do we have triangles that we could just figure out each area and then add them together?
Oh, we do.
So, look, that's where I told you
No,
to
but that's not the A part.
look at the perpendicular segment.
That's what I.
Okay. So 10 times 13 over 2. Okay, so that's why I said to look at the perpendicular segment first.
And look,
Okay, so 10 ends up being perpendicular to 13, so that's why I know that has to be the base of triangle ABD. And then look at the other perpendicular segment, it's 8.5, and it goes perpendicular to DC. So I can figure out each triangle separate. So triangle DBC has an area of 17 times 8.5 over 2. So what's this triangle on the top left? What's that area? 65. And what's this one? This one ends up being 17. So now we're going to find the total area by adding them together. And we get 137.25 good centimeter squared. Yeah. Okay, so you could have done a bunch of, the problem with doing right triangles, like here's a triangle, here's a triangle, here, but you don't know like the other measure. So that's why I have to just do this big triangle and this big triangle. You're gonna do the same thing here. So which one?
No, I get it.
can't you just do
Do
18
9
times
times 37 and over 2, and then you do 18 times 37.
Yeah. Can't you just do that?
This FH, so look what it says underneath. It says FH is equal to 37. So you see how 9 is perpendicular to this and 18 is perpendicular to this? This measure here is 30. So you just use 37 for both of the bases. So you do 9 times 37 over 2, and then 18 times 37 over 2. Okay. So the 9 times 37 over 2 will be this triangle, the top right, and then the 18 times 37 over 2 is the bottom left one. Thank you. Okay.
No, yeah, we only have one more page, yeah, it's split up.
Do you guys get 499.5?
I'm adding that?
Yeah.
Oh.
Did I do that?
Yeah, that's right. That's right.
Right. Everybody gets this for the final answer?
Really, what are you doing? You're taking a math class.
Okay, this is just applying. All right, so for A, they show X is outside of the parallelogram, but they just extended the side that has 9. So X is really referring to the height. Can you recognize that? This is H. So we know for a parallelogram what is, right, so area is base times height, so let's just plug everything in. We know 153 was provided, that's the area. The base is 9, so it's just 153 equals 9 times X. Not over 2 for parallelogram. That was just triangle. Okay, so divide both sides by 9. And get 17. How about the next one?
Oh, it's just what's divided by.
Okay, hold on. They just gave you a different picture to kind of trick you. So if this whole thing is 41 and this piece is 11, what's the actual base? This is 30. So 65 equals 30 times x divided by 2, right? Base times, I don't know. I just I took these examples so that when you encountered it in your homework, that there might be one like this, that's all. It's not that it's particularly hard, it's just they threw out this 11 centimeter part.
Coincidentally, that's equal.
We get 11?
Because there's an 11 in the book.
So if we know that, this should be what type of triangle? 45, 90. Oh yeah, I'm sorry, we didn't put units. This is inches in the last one, and centimeters here. Oh, I don't need it. Okay, so the base of the triangle is twice its height. So if the area of the triangle is 49 square feet, find its base and height. If you like to, if you're more visual, you can definitely draw a picture for this. Okay, so here, the base of the triangle is twice its height. The base of a triangle is twice its height. So if the height is, say, x, then the base would be 2x. Okay, so does that make sense the way I labeled it?
Yeah.
Okay, so our height is x, our base is 2x. So now read the next part. The area of the triangle is 49 square feet. Find the base and the height.
I got it.
How do we set it up?
X,
No?
2x squared over 2 equals 49. Good job. Woo!
Does that make sense? Because it's base times height over 2 for a triangle is equal to 49. So we really get x squared equals 49, right? The 2's just cancel. So x equals 7. So our base is 14 feet. And our height is yeah, because I just wrote out the base first. The base is 14 and the height has to be 7. All right. You have a homework. So you have a homework problem like this. It's not a difficult formula, but it's something. Heron's formula. So Heron came up with a formula for a triangle. Okay, any triangle. So the formula is the square root of x times s minus a times s minus b times s minus c. Okay, so s is what we call the semi-perimeter, or it's half of the perimeter of the triangle. Okay, and a, b, and c are the side lengths. So we're going to use Heron's formula to find an area of triangle with side lengths 5, 7, and 9. So picture here, just 5, 7, 9. This is not necessarily a right triangle. So S is equal to A plus B plus C over 2. So if we add these all together to find whatever S is equal to, so 5 plus 7 plus 9 over 2. For this formula. For the area of the triangle. Okay, so take a look at this triangle with 5, 7, and 9. This doesn't, do we know the altitude? No. Do we know any of the angle measures?
No.
Can we use trigonometry? I mean, there is another way to solve this, but Heron came up with this formula that will always work. So I can't do base times height. I can't do base times height divided by 2. No, it's just a problem on the homework. There's like one almost identical to this on the homework. That's all. So if he came up with this formula where if you add up all the perimeter, or add up the perimeter and divide by 2, and then using this formula, it will always give you the area of any triangle, okay? Without knowing the altitude. Huh? Of course. This is a real formula. Okay, what is S?
But you know what? I'm going to make a formula of that.
So S is 10.5. So the area is the square root of 10.5, and now you're going to take 10.5 and subtract each side length. So it doesn't really matter which one you say is A, B, and C, but if I take 10.5 minus 5, it's going to be 5.5. 10.5 minus 7 is 3.5, and 10.5 minus 9.
No, thanks for that.
How? You didn't have to use any, you didn't have to use trigonometry. You didn't have to use any special triangles.
Yeah, but then someone's writing.
Oh my goodness. Okay, so multiply this all out.
The answer is square root of 3 to 3.2.
What?
Yeah, that's nice. You get about 17.4?
I got, yeah, 17.4.
Okay, so we don't have time to do the last one, but you have one like this one. It's just basically use a 3, 4, 5 triangle and do the same thing, and then show that you get the same result with 1/2 base. Okay? I can fill it in. Yeah, I'll do it right now, real quickly.
Do we have to do the homework or is it optional?
Oh my god. Who gave me this pencil? Or pen? Roy!
You don't need to. It's, yeah, I guess you could.
These are look straight up.
Yeah, hold on one sec.
Gabby, tell me how you do, okay? You got this. Yeah. What's inside of it?
This case, can I keep this?
Mine has cubes.
Gabby, you do good.